Welcome everyone. I'm Garima Roy and I am here to demonstrate task 7.3D of SIT210, that is Embedded Systems Development, and the topic is Raspberry Pi PWM. In this task, the task requirement is using ultrasonic sensor to send a distant and actually put the output on the LED or the motor or buzzer. So in here I am doing with LED. So my LED will be brightened if the object was actually nearing the ultrasonic sensor. When it's actually far from the distant sensor, that is ultrasonic sensor, it will actually turn off the LED. The LED will going dim as respect. Here are the hardware requirements that we have using to complete this task. That is jumper wire, ultrasonic sensor, register, breadboard, LED, and Raspberry Pi. Here is the software requirement, that is Raspberry Pi and VNC server. Or v. This is how my hardware setups look like. Here, firstly I connect the LED to the breadboard, then connect the positive, that is longer leg of the LED to the one of the GPIO pins on the Raspberry Pi. Then I have connected the negative, that is shorter leg of the LED, to a resistor. Then connect the resistor with the ground pin on the Raspberry Pi. Then plug the VCC in the positive rail of the breadboard and plug ground into the negative rail. Then plug GPIO 5 volt into the positive rail and GPIO ground in the negative rail. Plug trig into a blank rail and plug the rail into GPIO 24. You can plug trig directly into GPIO 23 also. Then plug echo into a blank rail, link another blank rail using register. Then add GPIO 24 to the rail with your R1 register, that is register. Then the GPIO pin needs to sit between first register and second register. Here in the first to second line, I'm important Tinkler library. Then in third line, I imported the font library for giving the different styles to the font. In the fourth line, here I imported to use the bottom interface into the code. In the fifth line, I imported GPIO RPI.gpio library. Then in sixth line, I imported time library to get the current time in seconds, minutes, or hours. In the fifth line, here I am referencing to the GPIO. Then in the ninth line, GPIO sets as warning. In the 11th line, setting the pin mode system as BCM board, in which we will direct refer to the GPIO pins. Then in the 13th line defines here I defines in the 13th to 15th line, here I defines the pin to the ultrasonic, that is trigger on 23, echo on 24, and the LED on 12 respectively. Then in the 17th line, setting the trigger pin as output pin. Then in the 18th, setting the echo pin as our output pin. Then in 19th, setting the LED pin as output pin. Then in the 20th line, setting the pin mode, which gives variable frequency, and then setting the duty cycle. Then lastly, in 21st line, I initially state of LED is low by giving the zero value to it. Moving towards next slide. Here in the 23rd line, I made a method that is called distance. In the 24th line, giving the value of trigger pin as true. Next, I given a delay of 0.00001. In the 26th line, giving the value of trigger pin as false. Then in the 28th line, I iterates in this loop while its value is 0. Mm, then in the 31st line, I iterates in the loop that the value is 0 for echo to stop it. Then in the 34th line, getting the value of time elapsed by subtracting these two values, then calculating the distance and return the distance. Then test our system code that we have written inside try function. Then moving towards try, in the 14th line, uh, this loop iterates until any error comes. In the 41st line, this is used to get the data from the distance function. Then in the 42nd line, it prints the string which is written inside the command. Then in the 43rd line, if the distance is less than 50, then condition will execute. Then moving towards third slide. Here in the 44th line, I am changing the value of duty cycle of LED as a distance value. Then in the 46th line, I am setting the brightness of LED as 0 by calling LED underscore PWM dot start. Then in the 47th line, giving a delay of 1 second. Then in the 50th line, throw an error if try doesn't execute. Then in the last two line, here I printed measurement has stopped, and in the last line it will clean all the ports that we have used until now. Last but not the least, here are the program. Here we can see our project working. The LED gets brighter as the object approaches it. Here it is showing the distance measured. Thank you.